My name is Laurabel Haos, BS Ed Math 2. I am now presenting to you the method proof, the direct and indirect proof. Let's proceed to the example of direct proof. So the claim is the sum of any two odd integers is even. So proofs. Assume that m and n be the two odd integers. By definition of odd integers, m equals 2a plus 1 and n is 2b plus 1 for some integers a and b. M plus n equals, the value of m is 2a plus 1 close parenthesis plus the value of n. So the value of n is 2b plus 1 close parenthesis. So now we are going to use the distributive property. So let's combine like terms. So there is let's copy 2a, then 2b, and then so 2a, then 2b. Then this 2 constant, we are going to add that 1. So 1 plus 1 is equal to 2. So now let's find common factor. So ang ilahon on common is 2. Here. So then let's divide all of this by 2. So 2 divided by 2a divided by 2 is equal to a na lang, cancel ang 2, then a, the remaining is a, so copy a. 2 divided by 2b, 2b divided by 2 is equal to plus, copy addition sign, so b. 2 divided by 2 is equal to, copy the addition sign, then the answer is 1. So now our answer is 2 times the quantity of 2b. Our factor is 2 times the quantity of 2a plus b plus 1. Since 2 times the quantity of a plus b plus 1, we are going to see it 2k, where the k is where k is equal to a plus b plus 1. That is an integer. Since 2k is a definition of an even integer, m plus n is equal to 2k is an even integers. Therefore, we can conclude that the sum of two integers is even. So now let's proceed to indirect proof. So let's know first what is indirect proof. An indirect proof doesn't require us to prove the conclusion to be true. Instead, suffices to show that all of the alternatives are false. So there are two forms of indirect proof. The first one is proof by contrapositive, or as we call the other term is the proof of contraposition. So the second one is the proof by contradiction. So the proof by contraposition, which is sometimes called contrapositive, flip the script. Instead of assuming the hypothesis to be true and the proving that conclusion is also true. We instead assumes that the conclusion to be false and proven that the hypothesis is also false. So now let's proceed to its example. The claim is for any integers a and b. So a plus b greater than or equal to 15 implies that a is greater than or equal to 8, or b is greater than or equal to 8. Let's prove this problem. A plus b is greater than or equal to 15. So, it implies that a is greater than or equal to 8. And also, b is greater than or equal to 8 also. So now, we're going to prove by contraposition it is equivalent if a is less than 8 and b is less than, so if a is less than 8 and b is than 8, then the a plus b less than 15. We assume for any integers a and b, a is less than 8 and the b is less than 8. This follows that a is 7. So the value of a is less than or equal to 7, and the value of b is less than or equal to 7. So now we're going to add So, A plus B. So, 7. 7 plus 7. So, the answer is 14. So, 14. 14 is less than less than 15. That's it. So by showing that when A less than 8 and B is less than 8, so the result is A plus B is less than 15 to be true. So here is the sample. We have proven that for any integers A or B A plus B is greater than or equal to 15 implies that A greater than or equal to 8 or the B is greater than or equal to 8. By the proof of contrapositive claim, we are using OR statement. So you will always use contrapositive. It is because you are trying to prove an OR statement. It is extremely tricky. Therefore, when we are using contraposition, negate that OR statement and apply the De Morgan law. So, when you are applying the De Morgan law, or change into and which made our proof easier. So now, let's move to the proof by contradiction. So, this is one of the form of indirect proof. So, the claim here is for every integers n, if n squared is even, then n is even. So, suppose for the sake of contradiction, this is false. Assume there exists an integer n such that if n squared is even, then n is odd. By definition of even integers, n squared equals 2a for some integers, integer a, and b, and by definition of odd integers, n is equal to b plus 1 for some integers b. So let's prove. Then now let's do this. So n squared equals n squared equals 2b plus 1 squared. Because the value of n is 2b plus 1. When n squared, so 2b plus 1 squared. So let's simplify. Using distributive property. So 2 times 2, 4. B times b, so b squared. So then in order for you to understand, so let's do this. So 2b plus 1, 2b plus 1, 2b plus 2b, 2b times 2b, 4b squared. 2b times 1, copy addition sign, so plus 2b. The answer is 2b. Another, the second term, 1 times 2b, so the answer is 2b. 1 times 1 is 1. So combine like terms, so 4b squared plus 2 plus 2, 2b plus 2b equals 4b plus 1. So the answer is 4b squared plus 4b plus 1. So it follows that if n squared is equal to 2a, so then the value of n squared, so this one, plus n squared. So the value of n squared is 4b squared plus 4b plus 1. Then 2a equals the value of n squared is 4b squared plus 4b plus 1. However, this means that 2a equals 4b squared plus b plus 1. So let's transfer this one into the left side and the constant transfer in the right side. So 2a transfer to the right side, then the constant, which is 1, transfer to the left. So the equation would be, if we transfer this one, this is positive. So if we transfer in the left side, so it becomes negative 1. So copy 4b squared plus 4b. So let's transfer 2a to the right. So it becomes, so positive po ng yang symbol. This is positive, so it becomes negative. So, minus 2a. So now, we're going to get its factor. So, let's divide all of this term. So, the answer, the factor of this is 2. Negative 1. Atong i-divide siya og 2. Kay, if we divide in the right side, so, let's also divide in the left. So, 4 divided by 2 is equal to, before that is, negative 1 divided by 2 is negative 1/2. Then 4 divided by 2 is 2. B squared. Then 4b divided by 2 is equal to 2b. Then negative 2a divided by 2 is a. So the answer here is 1/2 is equal to 2b squared plus b minus a, which is contradiction as a and b are integers. Therefore, for every integers n, so n, for every integers n, that is n, if n squared is even, then n is even also. So, if this n squared is even, then the result is even also. That's it for the proof by contradiction.